The part A is asking us to show that cosine 105 is equal minus q, given that cosine 75 is equal to q. The rule that we are going to use is the supplementary angle rule. Cosine pi minus theta is simply equal minus cosine theta. That's it. Cosine 105 is the same as cosine 180, which is pi, minus 75. Using the above rule, that should equal minus cosine 75, and therefore cosine 105 is the same as minus a q, and that is what we need to show. On the graph in here, they give us the following information. BC is equal R, and they told us AD is equal CD. It's on the graph. D is 90 degrees, right angle triangle, and therefore AC is 2R. If this is R and this is 2R, we can look at this one, ABC, that's right angle triangle. The angle, the side facing angle A, BAC, is R, which is half the hypotenuse. Therefore, it should be 30 degrees. Or if you don't know that, we can use the SOHCAHTOA, and I say sine A. I can show it this way. Sine A is equal to the opposite, which is R, over the hypotenuse, which is 2R, and that's simplified to be half. Therefore, A is equal, or angle A is equal sine inverse of half, and we know the angle its sine is equal half is 30 degrees. So now we know this 30 degrees, so we know now this one automatically 60 degrees. If we know this one is 60 degrees, the side facing 60 degrees is equal the side facing 30 times root 3. So this side AB, I can write it as R root 3 from the special right angle triangle 30, 60, and 90. All right, so what do we need in B? Show that angle, the measure of angle BAD to be 75. Already we established BAC to be 30. Now notice AD, side AD is equal to side DC. That makes triangle ADC isosceles right angle triangle, and that means angle, the measure of angle CAD is equal the measure of angle DCA, and both they should equal, and they should equal 45 degrees each. So this is another special right angle triangle, 45, 45. Therefore, the measure of angle BAD is equal the sum of BAC plus CAD, which is equal 30 degrees plus 45 degrees, and that is 75 degrees in short. Now, CI, we need to consider the triangle ABD, so therefore I need to put a side in here. Let's see, make it in green, side BD, and let's fix it, side BD. That is side BD, and they want us by considering this triangle ABD to show that BD squared is equal 5r squared minus 2r squared q root 6. So obviously in here we're going to think of the cosine rule. Cosine rule, if you have a triangle, just a reminder, the cosine rule, A, B, C. This is side A, this is side B, this is side C. I can write A squared is equal C squared plus B squared minus 2BC cosine angle A. And the same thing can be done for each side. So in here I'm going to take BD squared is equal R root 3 squared plus this side is we need to establish CD. Remember that if this is A for isosceles right angle triangle, if this side is A and this side is A, the hypotenuse is A root 2. So A root 2 is equal to R. I can say A root 2 is equal to R, and I can establish A to be 2R over root 2. So A is equal to R over root 2, or simply R root 2. So I can establish that this is R root 2 R root 2. So this is R root 2 and this one is R root 2. So that is plus R root 2 squared minus 2 times R root 2 times R root 3 cosine the angle in between, which is cosine 75. Simplify that. BD squared is equal 3R squared plus 2R squared. Cosine 75 is a cube, so that's minus 2R squared. Root 2 times root 3 is root 6, and cosine 75 is a cube. Add these, that'd be 5R squared minus 2R minus 2R squared Q root 6 BD squared, and that is what they asked us to show. For double I, so this is CI. For double I, by considering CBD, find another expression. So we are going to look at the triangle CBD, the same thing. We are going to use the cosine rule and using BD, and the angle will be 105. So again, we are going to say BD squared is equal to, the sides are R and R root 2, so that will be R squared plus R root 2 all squared minus 2 into R into R root 2 cosine 105. Simplify that. That will be R squared plus 2R squared minus cosine 105 is minus a q. We proved that earlier, so that minus times minus, that will be plus. So R times R is R squared, so that will be 2R squared root 2 times a q. And if we simplify that, that will be 3R squared plus 2 root 2 r squared q. That is another expression for BD squared. Now, what else they want? D, show that using the answers that we get in part C, Ci and Cii, show that cosine 75 is equal 1 over root 6 plus root 2. Remember, cosine 75 is a q, so basically we need to solve for a q. To do so, all we have to equate the values of BD squared. So BD squared that we found in Ci is the same as BD squared that found in Cii, and I'm going to put that. So this is a 3r squared plus 2 root 2r squared q, and the other one is 5r squared, 5r squared minus 2r squared q root 6. Notice that every term has r squared. I can divide by r squared the entire equation, left hand side and right hand side, by r squared, by r squared, by r squared, by r squared, and that will simplify to 5 minus 2 q root 6 is equal to 3 plus 2 root 2 q. Now move the q's in one side and the constant one side. 5 minus 3, that will give me 2. And move this, becomes plus 2 q root 6, 2 q root 6 plus 3 plus 2 root 2q. Taking q common factor, that'll be, or before that I can even simplify further. Divide both sides by 2, by 2, by 2, by 2, that'll give me 1 is equal q root 6 plus a q root 2. Take a q common factor, that'll be root 6 plus root 2 equals 1. Make q the subject, so divide by root 6 plus root 2, root 6 plus root 2. Therefore, q is equal 1 over root 6 plus root 2, and that is same as what cosine 75, and that is what they want for this.